These are your notes for section 3.1. Chapter 3 deals with graphing linear functions. In section 3.1, we are going to specifically talk about what functions are. So the vocab terms that come up in this section are the following. We have a relation, which pairs inputs with outputs. A function is a relation that pairs each input with exactly one output. Domain, the set of all possible input values. So when you're dealing with this on a graph, the input values are your x values. So your your domain will be all your x values. And on a graph for the range, that's the set of all the output values. Your range will be whatever your y values will be. So range are your y values. Okay. Your independent versus dependent variable. The independent variable is going to be the variable that represents the input values of a function. And the dependent variable is the variable that represents the output values of a function. So your dependent variable, it depends on the value of the independent variable. This is a lot of vocab. I would like you to pause the video and write down the definitions, and we will address these as they come up in further notes. So the first thing to tackle when dealing with functions is to determine whether it's a function or not. So there's relations happening. This is an input value of -2, and the output value is 2. When the input is -1, the output is 2. When the input is 0, the output is 2. When the input is 1, the output is 0. And when the input is 2, the output is 0. So the first thing we're going to do, you might remember from last year, is we're going to make a function table. So if you look at it, we have -2, -1, 0, 1, and 2. And I just put all the input values in order. And then for your output values, we're going to have -2. Well, I would like to put, we have 2, 2, 2, 0, and 0. So we only have 2 output values, a 0 and a 2, and I'm only going to list them once. -2, when it's the input, it goes to 2. When input is -1, it also goes to 2. When the input is 0, it goes to 2. When the input is 1, it goes to 0. And when the input is 2, it goes to 0. Now, if you realize, every input only has one arrow coming off of it. Therefore, every input is only going to one output. This would be a function. It is completely okay that there's more than one arrow going to each output. That's not the definition of a function. The function is that every input has exactly one output, which is what is happening here. So it's okay that there's 2 arrows going to the same output. It just wouldn't be okay if there were 2 arrows coming off of one input. So let's look at B. If I were to line up my input values, we'd have -2, -1, 0, 0 comes up again. We're just going to have it written once though. Then there's 1 and 2. So this is actually the mapping diagram. The output values, keep them in order, 3, 4, 5, 6, 7, and 8. And you only list the numbers that show up. So when the input value is -2, it goes to 3. When it's -1, it goes to 4. 0. Right here, 0 goes to 5 and 0 goes to 6. So 0 goes to 5 and 0 goes to 6. 1 goes to 7, 2 goes to 8. This would not be a function because the definition, every input has exactly one output. And because of this right here, this makes it not a function because the input of 0 doesn't go to exactly one output, it goes to two. And that's not allowed when it's a function. When you look at letter C, this would be a function because every input is only going to one output. There's only one arrow coming off of each input. You don't always have to draw the mapping diagrams, but I think that's an easy way for you to start to understand it. If you can look at this, you can say, hey, -2, -1, 0, 1, 2. My x's only show up once, so that's great. Here you have two x's that are the same, and they're going to different output values. So from this table, you can see that it's not a function. The vertical line test. A graph represents a function when no vertical line passes through more than one point on the graph. So let's enter those in there. So again, the vertical line test tests whether a graph represents a function when no vertical line passes through more than one point on the graph. So we can use the vertical line test to determine if a graph is a function. So for the first graph, for letter A, I'm just going to draw some vertical lines. So the first vertical line hits the graph once. That's great. The second vertical line hits the graph twice. Right away, we can say not a function. So what this means, the vertical line gives you a fast answer. I just want you to completely understand that in this relation, when the input is 1, it goes to 0. When the input is 2, it goes to 5 and 2. So we'll have 2, 5, and we'll have 2, 2. And that is an input value that has more than one output. Therefore, it's not a function. Doesn't pass the vertical line test. For graph B, when we draw a bunch of vertical lines, and they can even go in the middle because it's a constant line, but any vertical line that I draw, it's only hitting the graph at one spot every single time. So that makes this graph a function. Now it's time on your own to decide for letter D, E, F, and G, and also number 8, if these represent functions or not. Pause the video and answer the questions. Here are your answers. For letter D, it's not a function because if you look at the input value of 4, it has more than one output value. 4 goes to 0 as well as 4 goes to 3, so that's not a function. For letter E, it is a function. Every input value only goes to one output value. Letter F is not a function because the input value of 1/2 goes to 3 different output values. It's only allowed to go to 1. Letter G is not a function because when you do the vertical line test, there's several input values that go to 2 output values. So that is not a function. It doesn't pass the vertical line test. And the last one in letter G, number 8, is a function because when you do the vertical line test, it passes. Example 3 is going to talk about finding the domain and the range of a graph. So as we talked about in our definitions, domain are all the input values, also known as your x values. So your domain, there we go. The domain will be the x values for this graph. So we have an x value here at -3. There is an x value here at -1, an x value at 1, and your last x value is at 3. So those are your domain values. For range, we need to know the output values, which are the y values. So from the lowest y value, we see it's at -2. Your next y value was at 0. And I drew over the dot. There's a dot right here on the graph. And then your next y value is at 2. And your last y value is at 4. So that's the list of your range values. Now the domain and the range for the next graph is a little bit different because if you see there's a continuous line for this graph, whereas the graph in letter A was just 4 different points. Because this one is a continuous line, our domain will be slightly different. The lowest value for our domain will be at -2, that's the lowest x value. The highest value of our domain will be at 3, and the x values are everything in between them, including -2 and 3. Because the x value, if you look at 1.5, there is an x value at 1.5. The input value of 1.5 goes to an output value of 1. Your range will be all the y values that are greater than or equal to -1, because the lowest y value is here at -1, and the y values will range all the way up to +2. So y's are greater than or equal to -1, but less than or equal to +2. I'd like you to pause the video and state the domain and range of the functions below. Unpause it when you're done to check your answer. Here are the answers that you should have come up with for letters C and D. The domain for C would be -2, 1, 0, 1, and 2. The range is 0, 2, and 4. You list them from least to greatest. Now for letter D, because it's a continuous line, the domain will be anything that is greater than or equal to 1 and less than or equal to 5. And then your range for your y values, you start at 0, so y is greater than or equal to 0, and it goes all the way up to less than or equal to 4. All right, example 4, last example. You're going to identify independent and dependent variables. The function y equals -3x plus 12 represents the amount y in fluid ounces of juice remaining in a bottle after you take x gulps. Identify the independent and dependent variable. So for your independent variable, one thing you should know is that it is the x values, okay? So I just want you to learn your independent is always on the x-axis. Your dependent variable will be represented on the y-axis. Now the dependent variable depends on the independent variable. So we have 2 variables happening. We have gulps and the amount of juice remaining. So you need to ask yourself, is the number of gulps dependent on how much juice is left, or is the amount of juice dependent on how many gulps are taken? And the answer is the amount of juice depends on how many gulps are taken, because if you take 1 gulp, only a little bit of juice is gone. If you take a lot of gulps, well then you don't have that much juice left. The amount of juice is very little. So the independent variable will be gulps. And in word problems, take the time to identify what the independent and dependent variable is. It will help out so much when you're trying to answer word problems. The dependent variable is the amount of juice remaining. Now for this first example, they actually told you that the amount of juice remaining is y, and the gulps is represented by x. So if you know what x and y are, x is your independent, y is your dependent. We have, for letter B, it says the domain is 0, 1, 2, 3, and 4. What is the range? So you're like, I don't know what you mean by that. So this is part of the word problem. We have an equation that says y is equal to -3x plus 12. So I told you that domain are your x values. So if I have, let's say, gulps, which are my x values, if I have 0 gulps, 1 gulp, 2 gulps, 3, and 4, we'll bring this up. what will be the y values, which are represents the amount of juice remaining. So if I take 0 gulps, we're going to plug 0 into x's spot. -3, we'll put this over here. So -3 times 0 plus 12. Well, that just equals 0 plus 12. The amount of juice will be 12 ounces. If I take 1 gulp, it will be -3 times 1 plus 12. So we have -3 plus 12. The amount of juice remaining will be 9 ounces. If I take 2 gulps, -3 times 2 plus 12, well, -3 times 2 is -6, plus 12, we have 6 ounces. I'm going to draw a line here. Okay, for 3 gulps, -3 times 3 plus 12, so we have -9 plus 12, we have 3 ounces remaining. And finally, when we take 4 gulps, -3 times 4 is -12 plus 12 would mean we have 0 ounces of juice left. It's all gone. So after 4 gulps, there's no more juice remaining. So the range would be right here. 12, 9, 6, 3, and 0. So to tie it all in, your range represents your y values, which are also known as your output values. The domain represents your x values, which are known as your input values. And this concludes your notes for section 3.1.